Good morning and welcome. As most of you know, I'm Nancy Greenwald. I'm the Executive Director of the Construction Institute. This is the third in our Tech Trio series for 2021. The first two presentations on PropTech and on blockchain are available on the website for this program, and you can find both of those there if you'd like to see them if you missed those. I want to remind everyone who's participating in this that it's a very informal structure. We're going to be having a conversation with an incredible panel of experts. I'm just thrilled about the group that's going to be talking and sharing their knowledge and their information today. And we do have AIA credits and other CEUs available for the program. If you need them, please reach out to us. You can reach out to me or admin@construction.org to learn more about that. So without any further ado, I'm going to turn the program over to Eric Sanford, who's been a moderator for the programs and is going to introduce himself and the panelists, and we'll get the conversation going.
Excellent. Thank you, Nancy. Welcome, everybody. Today, we're going to be speaking about artificial intelligence. And in this talk, like Nancy said, we are not a huge group here, and we want it to be conversational. So think of it more of a conversation than a presentation. There will be certain points that each one of us want to get across and want you all to learn. But feel free to ask questions, make comments, be part of the conversation. So Phil, we'll start with you. Why don't you take about 30 seconds to introduce yourself and let us know what you're working on?
Sure. I'm Phil Bernstein. I'm an associate dean and a professor adjunct at the Yale School of Architecture, where my work is primarily on the relationship between the role of architects in the building industry, technology, and project delivery issues. Prior to my job at Yale, I was a vice president at Autodesk, where I led the BIM initiative there for many years. And prior to that, I was an associate principal at Pelly Clark Pelly Architects. I have a book coming out in early next year, published by the Royal Institute of British Architects, on artificial intelligence and its implications for architectural practice.
All right, Dan, how about you?
Hi, my name is Dan. I am currently a product manager at Facebook AI Applied Research, where I take a look at how we can apply the latest technologies in machine learning to a variety of different problem types. I've been in the machine learning industry for quite a few years, and prior to Facebook was at Airbnb working on search, and then at Etsy for a time, and then in the ed tech world.
All right, James, you're up.
Hi, everyone. James Chong. I'm with AECOM, the digital consulting leader for AECOM, and have been involved in AI for some time as well. I've been involved in a lot of smart city, smart transportation, smart buildings kind of areas across the globe, and obviously working with both construction as well as technology industry experts. And I think this is a fascinating topic that we're going to be talking about today. I'm based in the DC area, and was traveling quite a bit until obviously we all got into the lockdown. But really glad to have all of you, and look forward to meeting you and kind of learning the interests further today. Thank you.
And I'm Eric Sanford. I'm Director of Virtual Design and Construction for Demio Construction. Right now, what we're doing with AI in particular is really just exploring it, seeing what's out there that we can apply to our tasks and really free up some of the burden off of our talent. I think we all basically have an understanding of what AI is. I think that I did, or I thought I did before I started talking to these gentlemen. But to get a better understanding for me, I did a quick Google search and looked up, just what's the definition of AI. And, there's a bunch of definitions out there. Basically, they are all pretty close, but it differs based on who is saying it. You know, some of it's sales pitchy, some of it's not. One thing that really I've learned over the last couple of weeks, speaking with the other panelists, is that I don't know anything about AI compared to these folks. So hopefully we can get you to the same level of understanding of AI that they got me. And one thing for certain, you know, when we talk about AI, you know, I have to throw a slide in like this. This is not what we're talking about. The AI is not coming for your job right now. It's not coming for your kids, or you're trying to turn you into batteries. So we'll let the other three explain what it is.
Great. So kind of picking up where Eric left off, AI can mean a lot of different things to a lot of different people. But when we hear the word AI in industry, often what we're talking about is machine learning. And so a lot of this jargon gets thrown around AI and machine learning. For the most part, those two are pretty interchangeable. And so I'd like to start off by giving a few kind of thoughts on what really that is and what that means. So I'll start with traditional kind of computers. In a traditional computer setup, you think about your goal. Someone programs the instructions. They write down what the computer does. The computer does that thing, and then you observe the results. And this works really well for certain tasks where you can write down an explicit set of results. You know, something like where that might break down might be driving a car, right? You can't exactly write a rule book for what to do every time a car is trying to navigate a road, just like you can't write an explicit rule book for like identifying, an unsafe piece of construction in a program. So the next step is machine learning, and that's where this piece comes in. And on the next slide here, we'll see how that changes. And it's a little bit subtle up front, but basically the big difference is, well, you still think about your goal. You set up the computer to learn. So instead of writing the program, you set the computer up to learn its own program. Then the computer runs the program many, many, many times. And each time it messes up. But then it observes those results and it changes its instructions in a predictable way to improve the error. And so there's lots of ways to do that, lots of tasks you can apply that to. But that's the general setup for all of these pieces. And that's why we call it machine learning. It's because there's some kind of experience that the computer program has, some kind of data, and it gets better over time. But that means we need a few things for AI to really work, for machine learning to work. You need a quantifiable, concrete business problem. You need a team or a vendor, obviously, to hone and build the model. But then you need absolutely just tons of data. And so to give a benchmark here, good performance can take 10,000 training examples for some pretty simple tasks. Human level performance can take at least 10 million. And not every task is easily translatable into the kind of just measure the error problem that computers are really good at. And in particular, you need not just the data, but you need good data. So clean, machine readable information to make this work. So when we think about something like, when they're building self-driving cars, they're literally sending cars out there to collect data and to learn from experiences. I see them in the streets of San Francisco all the time. They just have them driving around all the time, collecting this information. Areas that are a little bit closer to home, like search data, on Amazon, every single thing that you buy, every single transaction that you have, they're logging in a really clean way. So one of the questions for construction is, at what point are we going to have these pieces? At what point are we going to have data, and maybe it's in a specific subdomain, a specific problem or task that fits this bill, perhaps shared across multiple customers. So for example, if there's one vendor who's collating lots of different customer data around a problem, then we might be able to get there. But this is kind of the checklist that you should be thinking about of when can a machine actually learn to do a task that'll really help drive performance.
So I got a quick question for you, Dan. We mentioned clean data. I have used it in the past, but after talking to you, I'm not 100% sure what clean data is. So when you say clean data, what do you mean?
Yeah. So for example, you might have a lot of information on jobs that you're doing stored away in different spreadsheets. But if all of those spreadsheets have kind of a different format, then a machine isn't going to be able to go in and just crank away at the information in there. So generally what we're talking about is some kind of database of information that someone is actively maintaining that puts a premium on making sure that all of the information is filled out, making sure that all of the numbers make sense, that there's nothing kind of manually entered in.
Excellent, thank you. And then what are we looking at for a deliverable from the AI?
Sure. So one way I think of this is, pick a solid problem that you want to knock out. So a lot of times when people go to, I've seen it in vendor presentations, I've seen it in public discussions about AI, it's thinking about a lot of different kinds of possibilities. But it's more helpful sometimes to think of a specific piece that it can help you get better at. So, for example, in the legal profession, which is also kind of seeing where technology can apply, they were very specific about like, hey, let's look at document discovery. And let's have machines read text, which we have a lot of software out there that can do. And then that'll help us to identify keywords that'll help target people towards looking at specific documents. So there, it's not like a one-size-fits-all problem. They have a very specific question and a very specific tech, and then they're able to help reduce the man hours necessary, the person hours to achieve that goal.
Excellent, thank you.
So Eric, you ready for me to jump in here?
Yes, please.
So extending Dan's argument here, in the building industry, there are a tremendous number of sources of data, whether it's information that's coming from models that various players in the delivery chain are creating, the automation systems that are starting to find their way onto job sites, computer vision, prefabrication strategies, other miscellaneous stuff like electric vehicles and building control systems. And then there are a series of these technologies like AI and the Internet of Things, blockchain, as has been discussed here previously. And so there are an enormous number of data streams out there, but there are two sort of structural problems the way Dan has defined them so clearly. Number one, these things are not very well curated. So even a bunch of building information models that are coming from a bunch of designers and builders and subcontractors all have different formats, they have different representational schema, they may use similar family structures, but they're not curated well enough that an artificial intelligence system can use them in any kind of repeated way to do the kind of training that Dan is describing. The other problem is there's just not enough of this stuff. We could take every single building information model in Connecticut right now, and we probably wouldn't have enough models to train an AI to do anything intelligent. So there is this kind of nascent question of with the matching of the opportunity of technology and the actual enabling of it at a point where it's going to become useful for those of us in the construction industry. And it's one thing to scrape the internet for hundreds of millions of examples of text sentences. And that's one of the reasons that, for example, natural language processing is a relatively advanced AI technology. But scraping the web for building information models or frankly, computer vision images of construction sites, much more problematic.
Yeah, I think, Phil, I agree with you. And maybe one thing just to kind of add to the question about what is AI, from my experience and what we've done from sort of the AECOM's, construction viewpoint, as well as where we can leverage technology like AI. I think what Dan also mentioned, previously is that, it's a learning system, right? So what we need to try to do is figure out what are the actual use cases in the construction industry or transportation industry or, different verticals to see how AI could be applied. And so one of the things that, we're trying to figure out on our side is not trying to focus so much on just the technology, but what's the problem we're trying to solve, and then getting that to become an actual use case, right? And so we're starting to see some real good results because we got construction project managers now, say, hey, we can use AI. Before, any kind of technology discussions were shot down. And some of the pictures on this slide, like we're now actually either trialing or testing or kind of using computer vision and machine learning to do some basic things that does make our jobs easier and their jobs easier in the industry. So I think what's going to be interesting to see is how many real sticky use cases come out of our discussions about AI and the technology utilization, because I think that's really going to be where the adoption from the rest of the market's going to come. And I think all of us are kind of learning this now, but I think really the key so far that we've seen that got the most traction is converting kind of the ideas into real use cases and then putting it into the different vertical buckets, right? Vertical market buckets. So it would be really interesting to see kind of how some of the use cases are developing, from all of us, but also from the audience as well.
But I also want to
So when
observe
you're-
that I think that AECOM is a really great exemplar to keep an eye on, because unlike the vast majority of players in the building industry, you guys operate at a scale that you actually have a whole lot of data, and none of the structural problems of risk and compatibility and interoperability and all that other kind of stuff that plagues the technology business in general in construction. So I think the industry in general will be looking to you to see how things go, because you're sitting on these giant pools of cross-disciplinary data.
Yeah. And I mean, like even on the construction sites regarding safety, which is a huge piece for every AC business. We've got some sites where AI is being used to figure out whether people are wearing the proper PPEs, right? The personal protective equipment. Because again, we were trying to do that manually, right? Having people sort of watch out for this, but now with cameras that are able to be placed in construction zones, we can actually create reports of how well we're doing at some of these sites. And so there's definitely benefits, and we're really in the early stages of figuring this out.
So I think for a company like Demio, and I think most of the players out there are probably our size as far as who's dabbling in AI, what do you have any suggestions on how we improve our data sets or get bigger data sets? Is it sharing? Is it, going across companies or peer groups or something like that?
Well, I can maybe comment briefly, but I think Dan and Phil, you probably have some ideas as well. But I mean, for us, it's really about having more people able to kind of validate certain data sets that are coming in, whether it's false or true. When we're right now working in some scenarios, machine learning basically is not going to detect that 100% accuracy. And so, when the data comes in, there are times where you need data scientists, right? That either on your team or somebody else's team to say, yep, that's true, right? And so as that process gets better, the data output gets better. So really today the effort is trying to make that clean, like what Dan said earlier, trying to make that more accurate, and then the results will be better. So that's kind of, just a quick comment on the question that you posed.
Yeah, I think that's spot on. And just to add a little bit of color to that, I think sharing data kind of anonymously and securely through vendors is probably going to be a big lever. And I've seen that in a couple of industries. Having worked in search and e-commerce, a lot of our biggest kind of sellers through these platforms are businesses on their own. But if we were to just build a model for them, for something as bread and butter and as advanced now as product searching is, it still wouldn't really deliver a lot of performance. But by virtue of the fact that we're able to share across all of these different sellers, not the specifics of what's going on, not anything private, but just kind of the general trends in the model training process, that enables us to just get to that volume of data that can allow predictions, it can allow kind of actions to be taken. And back when I worked in ad tech as well, we had clients who we were buying inventory on the internet on behalf of advertising agencies. We had a lot of these big advertising agencies who we were working with. Same thing. if we were to build models just individually using only their information, then it wouldn't have performed as well. And I think that kind of gets into this question of trade-offs. You know, you want to be able to get the best performance out of the data that you're providing, but you also need safeguards, right? And assurances that, hey, this isn't going to be used for anybody else's competitive advantage. This is going to be used specifically for one purpose and one purpose only, and that we know what that is and it's in the contract. So I think as an industry, it'll take a while for organizations to build that case. And to establish that kind of credibility that, hey, you know, if all of a sudden you give us all of this data, it's not going to be a breach. It's going to be something that benefits you and is secure.
That problem is really very profound in the building industry and much more profound than it is in things like, for example, advertising, because there's a lot of risk in the distribution and discoverability of data, not just disclosing competitive disadvantages and giving away your intellectual property, but there are all kinds of other very complex considerations about whether data is discoverable, is it properly curated, is my intellectual property being protected? And there are extremely strong disincentives in the construction industry for doing that stuff. So there's going to have to be some other magical influence here, either a third-party immunizer of some point at some point in the process, or some kind of legal construct that creates a safe zone, or some kind of global intergalactic cooperation agreement where enough players decide to contribute their data and they feel protected enough. This is a big problem for us.
So here's a question, which is, can you, or do you see the application of a blockchain technology to provide a buffer and some anonymity, but to allow for the collection of data in a way that could be useful? Could that be a connecting feature?
I think that blockchain would probably make me feel better about the provenance of the data, meaning I'm an architect, I give my model to Eric, and I know that he's not going to screw around with it, which is what I'm worried about. But I'm still extremely worried that A, he's going to use it for things that I didn't anticipate, and so I'm going to get in trouble. Or B, my intellectual property is going to escape. Or C, I haven't been paid for how he's going to use that model. And blockchain doesn't help me with any of that stuff.
Right. Yeah. And I think the GDPR kind of things, which is more about data protection, that Europe is now enforcing. We have also from the US side, a lot of federal mandates that, require certain protection of data. One fun fact that I share sometimes when I, talk to some of the folks in the industry is that, did you know in the last 3 years, right, there's been over 90% of the data generated since Adam and Eve. I mean, this is like at an exponential pace. And so we're living in the data world that we cannot ignore. And so, us talking about data, it also kind of goes back to the definition that I try to explain to people that are non-technical about AI. But, like the picture that you kind of, Eric, showed is what some people do come to, with robots and, all kinds of, science fiction kind of things. But in my opinion, the definition of AI could even be simplified to say it's using computers or technology to convert data into information, right? That's really what AI helps you to do. So then people, starts, I can see that, and I think it's a good starting conversation. But great point, Phil, you made as well, and really the data is how everything now is starting, and it's figuring out how to manage that and work with that and visualize it is where AI can help us to do that.
I love that definition, James. I think that really gets at the heart of the issue.
Yeah.
So, Eric, should I jump onto this slide?
Yeah, I think so.
So I drew this diagram to try to describe in this book that I just wrote what I believe to be the broader arc of technology timelines in our industry, and to kind of boil it down to a simple construct here. In earlier times, all the information that James is talking about was analog, and we did that for several thousand years. Then we went through a brief period when computers got powerful enough that AEC professionals could afford them, that we started to see the broad expansion of CAD. And then when the next generation of machines and technology came along, we switched from CAD, which was essentially a drawing technology, to BIM, which was a modeling technology. But what I will argue in a moment is we didn't do much with it. And I think we're in what I'm calling a digital interstice right now, between now and probably when artificial intelligence gets mature enough that we begin to see informational integration. We're in a kind of a place where lots of things are getting digitized, but they have very anecdotal relationships to one another. The building industry is starting to get heavily digitized, and that the denominator of that may provide some coherence is artificial intelligence. So there's two ways to look at what that means in terms of the evolution from left to right on this. As an architect, I'm interested in this question of design representation, which is how is the thing that we're trying to build represented, and what kinds of increased capabilities does the technology make possible? So as we got better at drawing things, as you move from hammering things on stone tablets to drawing things with feathers on pieces of paper, we got to draw and represent and build more complex things. When CAD came along, we could document those things faster, and we could do more geometrically complex things. When I was at Autodesk, I used to claim that I could drive around an American city and say, hey, that's an AutoCAD 10 building, that's an AutoCAD 13 building, that's an AutoCAD 20 building. Because whatever we put in the tool, people started doing, hey, look, it's curvy, right? Then BIM came along, which was a representational shift. And the idea of BIM was, let's start making digital prototypes of buildings and extract drawings as reports. But unfortunately, the coefficient of friction being what it is, people are mostly using the BIM tools to make better drawings. The data is not really that exciting, frankly. So what's going to happen, I think, is we're about to enter into a period of what I'm going to call representational oscillation, with lots and lots of different kinds of representations going on. And we'll need some informational strategy to create coherence. And I suspect that AI will give us new capabilities, but will also give us the possibility of representational coherence. And one of the reasons for that is that with the advent of digital technology, there becomes a distinction between automation and autonomy. Machines help us automate things. So CAD helped us automate drawing, and BIM helped us automate the organization of information. But artificial intelligence gives us some degree of autonomy, meaning the machines begin to do things that we don't do ourselves. And you can see the early emergence of that now with scripting and generative design, but that stuff will eventually meld into more autonomous machines. But my thesis is, and it's an untested, some academic wrote it in a book thesis right now, that's me, is that we can't get to any kind of information coherence and therefore get to this kind of autonomy without AI operating in both realms. It has to operate in both the creation of autonomous processes and some autonomy around creating information coherence. So really that's what this diagram is meant to describe, if it makes sense. So Dan, James, Eric, critique my argument.
Well, I don't have a critique. I think that I'll leave that to Dan and James, but my big thing looking at this and listening to you talk right now is I'm scared, right? Like as a not in the big picture of like they're coming to take my job. They can have it if they want it, but it's there's so much data, like James said earlier, there's so much data that's been generated in the last 3 years that it's just crazy. The technology improves so quickly and changes so rapidly that my fear is in being able to keep up with it, being able to position my company in a way that not only do we capture data in the right way and that we are using it in the right way, but sort of planning that AI integration. And that's my big fear, that I'm going to miss that.
Before these guys respond though, let me administer a little bit of technological therapy as a former vendor. Okay.
Okay.
The idea of building information modeling conceptually emerged in the late 1960s. The technology began to become available in the late 1990s. My company spent $130 million acquiring Revit Technologies and another $500 million investing in that technology, Autodesk, from 2002 until 2021. It's now 2021. Has BIM completely rocked your world? It's been 3 decades.
Mhm.
Technology uptake in the building industry is unbelievably slow compared to the rest of the world.
Yeah, I
Compared to,
mean, that's,
I mean, you know,
that's the saving grace for me, but
Yeah.
it doesn't, you know,
doesn't make you feel
I don't
anything.
want it to.
So one of the pieces that I really love about this graph here is kind of that wavy line area in the data integration piece. And I think that that speaks to this question of, so data uptake, in the AEC industry, it tends to be slow. And the follow on is why. And I think that the answer is because there's a lot of complexity and there's a lot of change involved, right? It's much more complex.
Lots of ambiguity.
Yes, and a lot of ambiguity. And it's hard. It's possible in principle, but it's hard to, codify ambiguity in kind of a computer data set. So, an example of this is if you imagine a vendor who comes to you and they say, hey, we can improve your margin on project management for large construction projects by 5 to 20% is what our clients generally see. If you give us all of this data in this format, well, that's going to be a huge project for you to get all of your data together in that one format. But if it's an existing vendor and they have a track record and you know that profitability is out there, it's going to be a no-brainer. The problem is it's a flywheel. And to get the flywheel spinning, you need that company, that vendor to be able to offer that, to have that credible history. And for them to do that, they have to get the data in the first place. So it's the snake eating its own tail. And the question is, how do you spin that flywheel up? So I think one of the interesting areas where we're thinking where is this going to make a difference is to find use cases for AI in construction that rely on non-specific construction data. So for example, that might be something that helps with the process of, personnel management, and it runs off of your emails. The data in that case is text, and it might be fine-tuned on, the emails for large organizations. Or maybe it comes in the area of image, recognition, where you can train an image model to learn in a self-supervised way about the world, and then fine-tune it on quite a bit of construction data, but you can catch a lot of images by having a drone fly around construction sites.
We're going to look at an example of that in a minute, right?
Yeah. So Eric, to kind of circle back to your question, I think that there's a worry of getting left behind, but there's also a worry about getting pulled too far out front. And I've also been on the vendor side, and I've also audited vendors of machine learning technologies. And I think that's a point where you don't want to buy the monorail, right? But you also don't want to be lagging behind. And I think that just takes a lot of work and a lot of kind of pressure testing of these technologies. And the best response to that is kind of education. So is there someone on your team who's maybe built they don't have to be an expert in AI, but have they built one of these systems before? Do they kind of get the vibe of how these things work? And can they smell opportunity versus fluff? And that, I think, is the biggest antidote. And maybe you don't have that person focus on bringing AI into the organization, but you have them focus on a domain. And then part of their job description is to say, hey, of all of the tools, maybe this is one that can also benefit.
Yeah, I think, Phil, your theory is actually, pretty well packaged here. I think also some of the phrases that you use are very similar to what I was saying about converting data to information or meaningful information, where we can use the tools and AI and technology to do that. I think that the adoption of it, is going to be where it may take a little bit longer time period for us to get there as an industry. I think that, just the lessons learned and best practices are still kind of developing in construction, and also just in terms of what I would call more as companies' abilities to really go through the digital transformation. And, I think we've also talked about, digital quite a bit in the past, few years. What the pandemic has done, though, actually has, I think, accelerated that digital transformation. So maybe we've caught up a few years, right? Versus what the pace was that we were going at. And so, I think your book's going to sell well, in my opinion. I think your theory here is going to be very interesting to read up on. But also, again, I think at the end of the day, we got to bring it down to some practical use cases, real scenarios. And then as people start to see the benefit, we're going to create this little tornado storm, right? And so, almost like the crossing the chasm, which I'm sure you've all heard of, it's really, we're trying to cross that chasm over to that AI and digital and data side. And, again, the AC and the construction industry just traditionally have been known to be, laggards, right? They're more risk adverse. And so they want to kind of make sure people can jump over that first before they get into that tornado stage. I think the part here is exciting because we're literally living in this period where I believe we are going to see what happens, not just kind of hope, our generations afterwards are going to be able to see it, but I think we're living in this time zone where we're going to see some of this.
Excellent. So I guess, Phil, we'll go right back to you on.
Yeah, I mean, I don't want to spend too much time on this thesis, but I want to talk a little bit. When I was researching my book, I was working with a guy named Mark Graves, who's the head AI researcher for the Northwest Federal Research Laboratory. And Mark has this really interesting construct. He says that there are 3 escalating capabilities of an AI system: evaluation, which is like figuring something out; simulation, which is being able to create a context in which you can do some prediction of outcomes; and then ultimately generation, which is coming up with new kinds of ideas. And so if you look, the kind of processing structure that is parallel to that previous slide that I'm proposing is that, there are 4 categories of processing capabilities that you can look at in these buckets, right? There's humans who use like their intuition for evaluation and their experience for simulation, and they generate things by designing things. And then you have these computational systems. And so the systems that Dan first described when he talked about sort of first generation computers are algorithmic, right? You write a protocol, an algorithm, and it does this stuff. It does energy analysis, or it does proto simulation through BIM, or it does scripting. The machine learning systems that Dan is describing, I call empiricist systems, which means they take a bunch of empirical data, they do statistical correlation of it, and then they try to figure out how to do things. So they look at statistical collections of data, they test out different scenarios like how to play Go or how to play chess, and then they might even generate ideas by statistical extraction, but they don't have, there's no real intelligence there. And the next generation of AI systems are what I'm calling cognitive systems, which are models of the world, about how the world actually works, what inference means, not to figure out statistically what happens when you put a 2-hour wall in a building, but to actually know that a 2-hour wall has meaning and that it deflects fire, and I'm trying to deflect the fire. And those cognitive systems do not exist in any way, shape, or form in the world, and certainly not in AEC. And so to me, the evaluation, simulation, generation arc will be what we as an industry can leverage in the empiricist stack. And we need to start defining those clear business case problems that Dan described earlier and start driving that particular column, because all this anxiety about a computer is going to take my job is not going to happen. Eric, there in your lifetime, in my lifetime, and likely even in youngster Dan's lifetime, no senior level person is going to lose their job to an AI.
So that leads me to a question that comes from our audience, which is which aspects of design and construction will see AI performing first, and why? Is it construction, and is it detailing? Will it be construction documentation? What areas do you see as being sort of the low-hanging fruit, I guess, would be one way to look at it?
Well, in my opinion, the low-hanging fruit is clearly the evaluation piece, right? It's like, can we begin to understand the implications of decisions that we make based on AI evaluations of tons of previous data. And I suspect that's the kind of work that James's teams are working on. I know that's the kind of stuff that the Autodesk AI teams are working on. And the kind of projects that Dan's doing are way ahead of where we are in construction, because A, they have more expensive talent applied to the problem. B, they've been working on it longer, and C, they have way more data than we do. But the building industry is characterized by a whole bunch of these kinds of questions that we could very easily start working on. Like, how much is it going to cost me to buy sheetrock in March of 2023? Something super simple like that can be really dramatically affect a project. I just want to know within the limits what a piece of sheetrock is going to cost me in 2023. Okay, so I've looked at purchasing patterns and projects and market data from 20 years, and I can tell you that based on market demand, manufacturing supply, and the types of projects that are being built, these pressures exist, and therefore the likely range of that cost of piece of sheetrock is X. I didn't eliminate Eric's cost estimators doing that, but I have a much better insight into something that's actually super important to the cost of construction. But it's not some kind of existential computer, Skynet inference. It's just a dumbass piece of data analysis, which would be great. Because right now, Eric cannot tell me how much a piece of sheetrock costs in 2023. He has no idea. He has to guess.
Yeah, my big thing with you look at estimating in general, it's just trying to get the estimators to use something new. They are the toughest nut to crack in my company for sure.
But to take my example, which I literally just pulled out of the air, if all of the construction cost estimators in the United States, and there are 1 million of them, according to the Census Bureau, which means there are 10 times as many construction estimators as there are practicing architects in this country, just for context. If they all took all the data they ever had in the history of their construction estimation experience and pumped it into an anonymized database, and we said to them, you know what, this data has nothing to do with the market conditions that you're going to use to actually price things in the future, but it's a giant database of the cost of sheetrock forever. That would be hugely useful, and pick the top 10 most price volatile components of construction that introduce the most cost risk. And suddenly we've got an interesting value proposition here. And then as an architect, if I'm specifying a building that has a ton of sheetrock that I know is going to get built in the middle of 2023, something might tell me, hey, guess what? This is actually a problem. You might want to look at a different option here. Does that make sense?
Yeah.
Makes perfect sense to me.
I think also just, with Nancy's question about the low hanging fruit, what we have seen and we're actually doing, in some cases, is really using AI and kind of the technology pieces of it for planning side of things, maybe even right before the design starts to take place. So on the planning side, if we're building or designing a new train station, we can also now start to figure out what's going to be the traffic load, passenger traffic, and what's the kind of the behavior that we're seeing now, even after COVID. Yeah.
I mean, so if you're doing an airport for the 6 existing airlines in this country, they have unbelievable amounts of data about passenger loads, equipment mix, all that stuff, schedules, all that stuff. And that kind of information properly curated could be incredibly useful if you were trying to design just the basic stuff, like how many airplanes are coming into this airport, and how many people are going to be getting off those airplanes, and how many cheeseburgers do they buy, and how long does it take them to get through security? Just basic, easy stuff, right? That's where we need the help.
Yeah. Even inventory counting is another very simple, quick, kind of a sort of a benefit, because, you know, we try to count what the inventory of our existing materials on the construction site looks like. You know, we kind of have to guesstimate, but now with AI and some simple digital cameras, we can actually tell you there's 456 pieces of this remaining, right? And that kind of information being much more faster and readily available, you know, is a big selling point of that kind of, you know, low-hanging fruit opportunities.
Exactly.
Yeah, so I think that that's a great example, because it comes back to that definition you had earlier about, you know, AI being this way to turn data into information.
Mm-hmm.
And if we think about the checklist of, you know, hey, do we have a clearly defined question? Yes. We're trying to figure out how much inventory we have left. Do we have the kind of data? Well, you can always take a picture. And on top of that, like, you know, one 2x4 looks pretty much the same as the next 2x4. And if you
Right.
stack a bunch of them in a big pile, or if you're counting pallets, or if you're counting cinder blocks, right? That's something where a computer doesn't have to do a lot of thinking to recognize
right.
the object,
Yeah.
and can go in, and every single one of those 2x4s becomes a training instance.
Yeah,
Right?
it's a great example. And the having some guy on the job site counting CMU blocks, cinder blocks, as you call them,
Yeah.
CMU blocks, or counting 2x4s is very expensive, right? Using some kind of computer vision, or
Yeah.
a scanner of some sort, or LiDAR, or a sensor of some sort is cheap these days.
Yeah.
And easy, and you can collect a ton of that data now. That used to be super hard to collect.
Yeah.
So the opportunities are clearly there. We just, my view of this from an industry perspective is the industry needs to declare a strategy around these things. Otherwise, and I say this with all the love in my heart, because I used to be a vendor, the vendors will go do whatever they think is most lucrative. We need to have a strategy that we declare that says, we think these are things that these are the things we think are important. Go work on this, and we'll help you.
Yeah.
All right, I'm going to push us forward a little bit. We got about 9 minutes left, according to my clock.
I just want to make a quick point here. The nirvana in artificial intelligence is this thing that Pedro Domingos, who teaches at the University of Washington, calls the master algorithm, which is an algorithm that learns how to learn, and we ain't anywhere near close to that yet. It's not there. That's the kind of uber cognitive model. It doesn't exist. So just quickly, my argument is that there are tons of current sources of AEC digital data, which are in the yellow boxes, everything from building information models at the beginning of the process to building control systems on the end of the process. And that as those things begin to converge through the filters of AI capabilities, we will see 4 types of opportunities in an AI-enabled AEC industry: the automation of design tasks, the evaluation of ideas for their outcomes, the automation of construction, and the autonomous operation of building assets. So at a high level, from a strategic point of view, it seems to me that those are the 4 categories that we ought to attack.
And when we looked at your timeline before, the autonomous process was somewhere around 2030, I believe. What if you had to continue, you know, looking at the crystal ball, what do you think the timeline is for reaching to those the blue outcomes?
Well, if I were to guess, the stuff on the right happens faster than the stuff on the left, and there's 2 reasons for that. 1, more data. 2, more money, right? I mean, you know, Eric, I'll bet money that you're having trouble hiring people right now. So you have a very strong incentive to automate your construction site, right? With floods and thunderstorms and fires, clients have a very strong incentive to optimize the operation of their building assets. And so there's 10 to 100 times more money on the right side of this diagram than on the left. So that's in my opinion where you're going to see things happening. And that's not a technological argument. It's just market conditions.
Yeah, no.
Yeah.
That's what drives it, right?
So, two examples of stuff that we're seeing out there. On the left is Norman Foster's office, the largest architecture firm in the world, using a Boston Dynamics robot to inspect a construction site. On the right is a startup that I've been following called Doxel that uses a LiDAR scanning enabled robot to run around on a little tiny tank so it can climb stairs and get over stuff. That goes around the job site, scans the job every day, maps the scan against the building information model, and evaluates with a degree of precision that probably scares Eric to death the percentage of completion of the project and the earned value of the project. So these are super, it's just super interesting examples of things that are happening out there.
Yeah, with the Doxel example, a few years ago, we tried out a handheld scanner called the Zeb One. I don't know if you guys know it, but basically it looked like a person was going around blessing the site. It was using SLAM technology, same idea, but it was a person, right? That they had to walk around and do the work. Then we had to process the point cloud. Then we had to compare it against the BIM for the project. And then we came up with, the PPC. When we compared that effort against the superintendent, or we showed it to the superintendent walking through it, he called us over to his big grease board on the wall where he had a laminated floor plan or a foundation plan. That was what we were scanning. And he said, take a look at what I can do. And he took a highlighter and he started at one end of the wall and he traced the wall until he got to the other end of the wall. And he goes, that's what we did today. That's for him. It was that quick to get the data, to capture that data. So, we tried that approach for 3 months now. It wasn't an autonomous robot. It wasn't doing the math for us behind the scenes or anything like that. So we were a little ways off from this Doxel, but we have that to go against. The highlighter on the wall is a quick way for them to sort of track, and that's our audience. That's who we're trying to get to sort of use the
right. But that, I think it's a really interesting illustrative example, because on a multi-$100 million building, cash flow is a function of some guy standing in a trailer with a whiteboard. Really? That's how we're running construction? Some guy guessing how much work that got done every day, or estimating.
Or they're asking, really, what did you get? Like when we start looking at poll plans and last planner, we're getting a better idea on what was done based off of the commitments and what they're able to say. But yeah, it's not as scientific as we probably could have it, for sure.
Yeah.
I think one of the interesting questions there is, could it get more accurate if instead of having someone kind of replicate this process with an autonomous system, you were providing them with more information faster so that they were able to make better decisions? And I think that that's how a lot of this might kind of trickle into the industry, is if you take subsets of these problems, I could have gotten a better estimate if only we knew X, Y, Z. And then if you have a system to go out and get X, Y, Z, and so you basically have the human in the loop, and you're turbocharging their ability so they can focus their time and energy on their expertise rather than kind of the grunt work.
Exactly. Like if you said to that job superintendent, what's the biggest problem you have tracking progress on the job site? What's the hardest thing to track?
Mm-hmm.
Okay, let's go figure that out.
Yeah.
So it seems to me that what I've just heard in the last few minutes points out two issues. One is to Eric's story, until it's faster than what you can do drawing that with the highlighter, it's not helpful. But then once you have the information, what do you use it for? So for example, understanding what the percentage complete is on various aspects of the project is very useful when you think about decisions about how, can you accelerate it? Are you behind? Does that information give you the opportunity to make decisions about putting more person power and a different part of the job to help bring the schedule into, into conformance with the contract. So it's not just what can we do, what can we learn, it's what does that enable us to do better? And that's certainly one area where it would help.
Yeah, so I think for me, one of the things that pops up with this, especially with the image of Doxel, the PPC part is pretty good, but the one thing that I watch, one painful act that I watch on the job site is, sort of that reconciliation of bills submitted. And when you look at earned value, $18 million, 18.6 million on this, it's probably that I could see more effectively or being used more, because then it's like, all right, this is the money that we're spending. It's not that superintendent or that project manager kind of guessing and saying, I don't think he did that much work, so we're not going to pay him that much, or he did a little bit more, it all sort of washes out. But when it comes to the money, I think that's huge definitely huge for it.
But that intersection of the builder wants to be paid as fast as possible, and the client wants to pay as slow as possible, and the design team is in the middle trying to intermediate and interpret in a kind of semi-fact free zone is an opportunity, right?
Yeah, exactly.
But so guys, we're at the top of the hour here. I for one, I'm going to have to move on to something else in a minute, so we should probably wrap up pretty soon.
Yeah, if there's no questions from the audience, I got my questions answered throughout this. I hope that my questions were some of the same questions that other people had.
I'm dying to know what the top two things James is working on this is before we go. You can disclose.
Well, we're doing some interesting projects, but definitely the return to service has been a big theme for us, and just from a infrastructure perspective, and so obviously that ties back into construction and planning. So we're seeing a lot of the cities and municipalities trying to figure out how do we get back to the pre-COVID activities, and also kind of figure out what's the right way to plan and design and move forward. And we're working on projects all over the world right now, but that seems to be a common theme. No matter where I go or who I talk to, is let's help us figure out from a AEC perspective, how do we do the proper planning and design, and ultimately create that outcome where we can get that, people back into service, whether it's traveling or working or something else.
So I'll take a moment to say thank you to all of you. This was an incredible discussion. I know I learned a lot, and I know our audience did as well.